Hello, good day, and welcome back to the Statistics and Mathematics Details course of Stochastic Processes. So, in today's video, we're going to look at irreducibility of a Markov chain. Okay, so a Markov chain is said to be irreducible if it has only one communicating class. If it has only one communicating class, underline this. If it has only one communicating class, remember in our previous video we looked at communicating classes and also accessibility among states. So as we will see shortly, irreducibility is a desirable property as it simplifies the analysis of limiting behavior. Okay, you not understand this, but stay tuned. We get to limiting behavior. It's very important. So now it means that in the Markov chain, there's only one communicating class, and if that happens, then there's an irreducible Markov chain. That means the Markov chain is irreducible. All right, great. Yes. So this is a proper definition. A Markov chain is said to be irreducible if all states communicate with each other. Simple as that. Alright, so let's look at recurrent and transient states. So a Markov states in a Markov chain are classified as either transient or recurrent. So a state is recurrent if once entered, the chain will return to its one. It will return to it with probability 1. That means that a recurrent state is a state in which when you exit from it, there's a possibility of coming back to it. Alright. Otherwise, is what is a transient state. If you cannot return back to it with a probability of 1 or with a certainty, then it's a transient state. Okay, great, great. Yeah, so mathematically, this is the definition for a transient state and a recurrent state. Alright, so these are just probabilities. This FII probability that Xn in n steps we come back to state what? To state I. Okay, yeah. So if this probability is equal to 1, then it's recurrent, otherwise it's what? It's transient. Okay, yeah. So if two states belong to the same communicating class, they are either both recurrent or both transient. Yes. For instance, if you have state 1 and state 2 being in the same or in the same communicating class, it means they should all be either transient or recurrent. If one is transient, once they belong to the same class, they should all possess the same properties, as in whether they are all recurrent or transient. Alright? Yeah. So this explains everything. I don't need to go over this again. Yeah. So let's look at the periodicity of states and classes, right? So the period of a state I, denoted d of I, is the largest integer d such that the probability of moving from state I to state I in n steps should be equal to 0. Okay? Yes. So state I is aperiodic if this periodicity, if the period is what? Is greater than 1. Okay? It's aperiodic if it is greater than, if it's equal to 1, sorry. And if this is greater than 1, then it is what? It is periodic. Okay? Yes. If the GC, this is actually the GCD. Alright? So all states in the same communicating class have the same period. Yes, just like the transient and the recurrent situation. Okay? Yes. So a class can either be what? If a class is either periodic if all states are periodic, and is aperiodic if all states are aperiodic. Okay? Yes. Let's look at the conditions for irreducible, periodicity condition for irreducible Markov chains, right? So we are saying that. So when do you say that a Markov chain is what? Irreducible? You only say this if there is a self transition. If there's a self transition in the Markov chain. Okay? Yes. If there's a self transition, and also the chain is aperiodic if and only if there exists an integer n such that the probability of returning or moving from one state to the other is what is greater than 1, as in there exists only one communicating class. If there's only one communicating class, then the Markov chain is said to be what? Irreducible. Okay? Yeah. Let's look at an example from the classes that we had from the other video. Realize that class 1 contains state 1 and state 2 if you watch that video very well. So the two are all what? Aperiodic. So you can see that the whole class is aperiodic. Same to class 2. Okay, and the same thing for class what? For class 3. Okay, class 4. So I think class 3 has only 5 in it. Okay, yeah. So that is that. Good. Yeah, yeah. So it's aperiodic since it has a self transition. Okay, yeah. And this it has a period of 2, no problem. So that's a period of 2. Let's look at why does it have a period of 2. That is state 3 and that was state 4. Why is the period all 2? Okay, so in how many steps? The period is actually the number of steps you take before you return back to the same state again. So so this is longer a bit, but we'll get there. So you see, when I move, how many possible ways do I move from 3 and come back to it? So you see, let's see. This is 1. I go to state 4, then I take my second step to back to state 3. So you see that these are 2 possible ways. The same thing for that of what 4. Yeah, the same movement. We move to state 3 in one step, and we come back to state 4 in another step, and that is what period of 2. Okay, good, 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 good. So that's how we got the period. Okay, yeah. So we've seen that, and this example has been elaborated very well. I've just explained how to get a period, how to get a period of a Markov chain. I've seen that. Yeah. So that's it for today's video. Thank you so much. And in our next video, we'll be looking at absorption probability. So stay tuned and have a lovely day. Thank you.